Okay.
It is actually very easy. After coming home, I am getting it correct answer. That is painful.
Okay, let's do this.
Yeah. Okay. Consider the graph G below. Okay. Let alpha denote the number of minimum spanning trees of G and beta denote the weight of such a minimum spanning tree. The value of alpha plus beta is.
Okay.
We should calculate the minimum MST first.
G.
So
What is the G? Okay, G is the graph, whole graph.
Yeah, G is the number of, alpha is the number of MST and beta denote that all the MST. But I got the answer correct. I think we get only one MST here.
Okay, how do we solve this here?
We can choose, one, right? A to H.
Correct, one.
Then H to B2, right?
Correct. Then we can't choose this.
3. And we can choose 4, H to F. I hope
Correct.
in the exam it was correct.
Yeah, H to F.
Then 5, F to D.
Yeah.
And
wait, 5, right? Okay, F to D, correct.
Yeah, then we need C also, right? So
B to D.
B to
D. B to D is 6, right?
Yeah. No, I'm talking about D is already there, no, Gokul. F to D. I've chosen 5.
Okay.
So you can choose now B to C because we need C.
So are you using any kind of algorithm to do this, or simply you're saying?
No, because this Kruskal is a minimum and we just joined, right? So that is what I'm applying actually.
Okay.
We can do that. This is the same method for Kruskal, right? You choose all the minimum edges and just combine.
So you forgot 6, I think. Right?
No, because I have connected F to D. You need B, right?
Yeah.
F to D edge I have done, no, Gokul. So that is 5. D is done, right? Why should I go for D to 6?
Okay.
You need all the vertices in the tree. That's all, right?
I think it will form a cycle if you are doing this. Will it?
I don't know, but
yeah,
I got
exactly.
the answer is
because B to H we already connected, and H to F is also connected, and F to D is also connected, right? So if you do B to D, it will be a cycle again.
That's what I told you. No, I'm not including B to D.
Yeah, okay, got it.
That's why I'm going for C.
Okay.
D to C and D to E, I think, because F to E is 12, so I'll choose.
My question is, why do you want to take D to C? Can't you take B to C because this is low, right?
Yeah. Today I'm lost. Yeah, we can do that. Sorry.
How do we take a minimum cost spanning tree, right?
Excuse me, Gokul, just to add. So maybe we can do one thing. We can just list down the edges and the weights as well, and then we can sort beforehand in the ascending order. Then it will be easier to pick up, right? Because we tend to forget what have we picked up and what we have not picked up. So that is.
So what do you want me to do? Can you tell me?
Yeah, so we can just take every edge that is there and kind of list them down in the ascending order of weights.
Okay. So AH, right? So can you just tell me?
Yeah, correct. Okay. Then I think it will be 2 only. So HB.
BH or HB, fine.
Yeah, okay. And then we go to 3.
3 is AB.
4,
right?
HF.
4, which is HF. We don't have any more 4, so we go to 5. Correct?
FD, yeah, FD.
Yeah. Then
BD, I think 6.
BD, correct. 6, and then we have 7, HG. We don't have any repetitions. We can directly go ahead. GF, right, and BC, and then CD, right? CD, DE, EF, FB. Uma, you follow what happened?
Yeah. Minimum you are sorting, right? Yeah.
Yeah, we are sorting it and writing the H's.
Yeah. So I can go ahead with AH.
Yeah, first one I'll take in caps. AH. Good. Then
BH.
BH. We cannot take AB because it will form a cycle. AH, BH.
HF.
Yeah, next is HF.
FD.
FD, yeah.
And the BD cannot be taken because it will form
because it will form a cycle again. Correct?
Cycle, I think, but yeah.
Yeah, it's forming a cycle. See, because BH is already there,
Yeah.
right? And then
Yeah.
HF is already
Okay. Okay. Yeah. Yeah. Okay.
this trapezium kind of.
BD we can't take. So HG. Yeah.
BD we did, then HG.
Yeah.
Okay. Good. Now GF you can't take because it will form a cycle like this.
Yeah. So
This triangular cycle.
BC, right?
Yeah, BC we can take. Good.
And D. That's all.
And DE. Okay. So
All are covered, I think.
yeah, EF is not required and
So
FB is not required.
There is no repeated weights, so I don't think we will have one more MST. I think, right?
That's the point over here, I think, right?
Yeah, I got
Correct.
that. Yeah.
So that's
So
the
alpha
idea.
will be, I think, denoting the weight of the total weight of the minimum spanning
Must be
tree. So that I
30.
think 39.
Yeah, plus 140. Yeah.
Plus one, I think that the exact numbers also I got in the paper. So it seems to be the same.
Yeah.
Which, yeah.
Okay.
But sometimes
So
it
40.
change. Yeah, I mean different
Yeah,
people.
sometimes it changes.
This actually
Okay.
I got after coming home. I got it correct with the example. No, check. I missed it.
The first question, huh?
No,
Or
the
second question.
second. It's 4 marks, so I really.
So what is this question actually?
You want me to read?
Yeah.
Consider a binary tree T that has 50 leaf nodes. Okay. Then the number of nodes in T that has exactly 2 children are. Initially, I didn't know how to calculate. After coming home, I thought one side if you draw 2 nodes and the other right side if you just, it's like a skewed one, only one child, then you will get this answer is what?
50 leaf nodes. Okay.
Yeah, usually the number of nodes will be 2n, right? This sorry, I think there is a formula there.
Anyone else also want to talk? We can talk. Afnan, you can talk if you want.
No, it's fine. Actually, I have a slight cough today, so I'll be talking less. Okay. All right. Yeah.
Usually there is a formula to find the number of nodes, normal nodes.
All right.
I think it is 2 into n minus 1, right? So I thought it is 99, but actually it is 49. You have to take only the half of it.
That has 50 leaf nodes. Okay. It's a binary tree. It's not a complete, it's not a full, nothing they have told. They just told it's a binary tree.
Yeah.
Right? Which means it's being split into 2. Sorry, I don't have a pen, so okay.
Yeah.
Then the number of nodes in the T that has exactly 2 children are.
So I took an example after coming home. The exam I lost it, so it was I have made it as 99. That is total nodes, in which everything has 2 nodes. That is the formula we have usually.
I remember doing this question some time back also. In the previous term also we had done this.
Okay. It was actually 99 nodes, right? If exactly they had 2 children, it is supposed to be 99 total nodes. But here they have asked only things which has 2 children, so it was very difficult. But coming home, I thought maybe one side we can have one children, right? If you take like that, then it comes out to be 49.
Uma, consider this scenario.
Yeah.
I'll just join them. This is just some random binary tree.
Yeah.
Okay, you don't need to worry. I'll just draw like this. Oh my god, it should go this. Okay, so this is a binary tree, right?
Yeah. I tried this kind of example. So it is like kind of one side it is skewed. So you are taking the only one half of the nodes, right?
Okay.
So like if you calculate 100 nodes, but according to this diagram, for 50 leaf nodes, one side will be single skewed, right? It may not have 2 children.
Wait a second. Okay, Uma, how many? What is that?
4, right? Here you're
Leaf
having
nodes are
4
there?
leaf nodes in your diagram.
No, 5.
5.
We have 5,
Okay.
including this.
Okay.
See, this is also you have one, right? Are you able to see this point?
Yeah. Okay. 5.
5 are there. Okay, and how many 2 children parents are there?
2, 3, 4.
4. You got it. So now see, I'm gonna draw more. Okay, I'm gonna make it exactly duplicating this. Very I have one circle here. Consider it as a circle. I'm gonna have a complete graph. Okay, Uma.
Yeah.
This is gonna come here. This is gonna white. Okay. Now, how many leaf nodes you have, Uma?
I'm counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10,
Yeah,
11,
you have
12,
8.
13,
No,
14.
only 8 leaf nodes. Where are you counting 9, 10, 11, 12?
Okay,
What
sorry.
is a
Leaf
leaf
nodes.
node?
Sorry. I'm tackling the 2 children node. Okay.
Yeah, leaf nodes means 0 children.
7, 8.
Got it?
Yeah.
Yeah, we have 8. Now, can you calculate the number of parents?
Yeah.
It will be 7.
Yeah.
It is the fact, it is always true. Okay, it is always, whatever the graph is.
N by 2, right?
Yes, even you look at this graph, Uma.
Yeah.
So that this is there is a circle. You have 2 children and you have 1 parent. So no, it's not n by 2. It's n minus 1. I mean, by minus 1.
Yeah, N by 2 because the top root node is only 1. No? So yeah.
Okay, so if you're having, the point I'm trying to say is, if you're having 50 leaf children, that's what they are saying, 50 leaf nodes, then the number of parents with 2 children is going to be that 50 minus 1, number of children minus 1.
Okay. Yeah.
It's the case, even if it is a single straight line like this also. Just imagine. So no parent will be like that, right, Uma?
Yeah.
The number of leaf node will be 1, I mean, right?
Yeah.
And the number of parent with double children is also 0.
Yeah.
Which is
Minus
1 less than the children.
Yeah.
Correct, minus 1.
Yeah.
So,
somehow I missed that.
yeah, we have done this in the previous term also, question paper. Here only in the sessions.
Somewhere we did this n by 2 thing, but I forgot. This tricky question, no, confused us. That exactly 2 children, things like that, really. Yeah. So
okay. Hope it's okay now, right?
Yeah, I got it. I just tried to example at home. It came out correct. I was going for total number of nodes, so it came as 99. That is wrong, right? So yeah.
Yeah. Anwar and Srivana, you guys want to talk something? You guys are texting the chat.
Oh yeah, we're just talking about.
We were just discussing something which Afnan has asked.
You guys want to discuss that? I think Uma also knows that.
No,
right,
same thing.
Send that code to Anwar. I am unable to paste in chat. I will send it to you. WhatsApp. You can send it off now.
Anwar, so Uma has got a solution for that question.
No, I sent it to Anwar. Maybe he will also. If he can send it in space with Afnan.
Okay. What is the question?
Yeah. So just to give this statement. So there is 2 lists, okay, and both are sorted.
Yeah.
And then we have to find the median, which will be the median if we merge the 2 lists, okay. But that we have to do without merging, of course, because if we merge, then the complexity goes up, right? So we need it in log n. So that is why we cannot merge, of course. That I tried in the exam also, but it was not passing because of the fact that it was not satisfying the complexity constraint. So I was not able to get that one. So I was just wondering what would be the approach for that one, because we cannot merge, but then we'll have to find the median if merged, right? So that is the idea.
Okay.
So is the question clear?
Yeah, the question is clear. Let's take a simple example. Let's say we have 2 lists with 3 elements each.
Okay.
And we want to find the median of the merged list, which is 6 elements, right?
Yeah, correct.
Now there are cases where the median can either be on the first list or the second list, right? Okay. So
Exactly.
What if I find the median for the first list somehow? There is a way to find the median of the first and the median of the second list. If I compare them, will one of them be one of median for the merge list? Is my question. Like, can you think of something in that sense? So if I have to merge, say 1, 2, 3, and 4, 5, 6, right? There's the first list has 1, 2, 3. The second list has 4, 5, 6. I don't think we have a median for that, right? Let's say 3 is the median, right? Okay. If I take the median of the first list, I'm getting 2. And if I take the median of the second list, it's getting 5. So that's not one approach. Let's rule that out. We can't take the median of...
Excuse me,
Yeah.
just to add on that one. So if the number, if the number of the elements is even, then we'll have to sum the middle two elements and then half that. So by 2, sum of the middle two elements and then by 2. The same thing that we do in finding the median in even number case, right? So the same thing here we also have to do. So in this case, it will be, I think, 7 by 2, because 3, 4 comes in the middle. Then we'll have to sum that and then we get that thing, right? So that's
Sum that. So 3.5, you mean, is it?
yeah, correct.
Okay. Um,
And in the odd case, it is easy
I
because you
mean,
just pick out the middle element. I mean,
median. Do you mean mean or median? I'm confused
median.
now.
Oh, sorry,
Can you
median.
send the question? Can you send the question somewhere? The link. I can share it on the screen.
Question. I don't think we have that
Uma,
because that was
can
the
you send
OPP.
it?
This Afnan, if Afnan, the code which we had,
I will
Yeah.
send the code to Gokul.
okay,
Just a minute.
I can send it. I can explain it also. The
Okay.
logic goes like, no, you find the median of both the lists first. Okay, by
All right.
simply doing
Picking
the
the.
n by 2 or n by 2 plus 1, whatever.
Yeah.
Take it,
Okay.
you take it like if it is odd,
Hmm.
whatever formula. If it is even, what is the formula pick? Okay,
All right. Okay.
then you compare both the medians. Okay,
That I think Shrivani
so you
also
see
suggested,
if
suggesting the
m1
same.
is less
Yeah.
than m2 or m2 is less than m1, or these two chances are there, right? Or
Correct.
equal to. Okay, so 3 chances are there. So if it is equal to, the median is same.
Okay. Yeah.
If one is less, it says then the median lies, like if it is m less than m1 less than m2, then median lies in the section of the first list 0
First half.
to 0 to m1, and second list m2 to the last element. Okay, so in that
Okay.
logic, you are eliminating half of the portion.
That's a great. Yeah, I think that's a very smart approach. Yeah.
Afnan, that explanation is
So
very
like
clear
that,
in
you
the page.
go on eliminating half, then you will reach both the list is having two elements. Then then from there, it is very simple.
Afnan, they have given a very crystal clear explanation also. It is very easy. With the explanation.
Yeah, that's nice. Yeah.
Yeah. Okay. I'll go through this one actually. Thank you for sharing the link. Yeah.
Yeah.
Okay.
Thanks for you too, because we cannot prepare. At least hopefully.
Yeah.
But
This one was in the
problem
OPP.
is,
Yeah.
this is only for the equal length is same. If the length is different, then the code I think differs. So that is the problem.
Yeah. It might be different. Yeah.
Yeah.
Will it
They
be
have the code also.
any suggestions on that one? Will it be
They
different?
have that code also, but I have to look into it. I thought maybe I was
Okay.
thinking that must be the same length. So that's what I want to ask you, whether the list is of same size or different size.
But that I'm not able to exactly recall in the exam whether it was the same size or different. Perhaps it was different. I mean, that's the best case.
And also there is one doubt, Afnan.
Yeah.
The median comes out a value which is not present in the list. So is it okay or?
Yeah, it is okay, because in the even case you see that you take the
The
middle two
value
elements
cannot
and
be
then you
there
have that,
present.
so it cannot be there, right? So
Okay,
it
then
is
fine.
okay.
This
Yeah, it is fine. Yeah.
Okay. So shall I continue where we left, Uma?
Yeah.
Yes, please. It is clear. Thank you so much. Yeah.
Okay, great. So we have more people. Would someone else want to take this? Hi Mahi. Hi Ravina. What? Afnan, can you take this question?
Yeah, you are audible.
Yeah, can you take this question? Let people take the next question. They just join.
Okay, can I directly give out the answer if it is matching? I think it is 5 only, no?
It's 5. Yeah, but
Yes, sir. It is 5.
let's solve this question.
Okay.
Yeah,
Then at least this one I got
solved
right.
this question by simply drawing it.
Yeah.
I put all the columns and just drew from two, whatever it is there, then counted. That's it. I thought that is a simple thing.
So how was your score of Anwar? What range your score lies in? Was it good?
I have not checked my answer sheet actually. Somewhere
No, they
I
released
have
the
made
score.
all the questions I knew, but some silly mistakes I have made. I think.
Exactly, that's what everyone is facing.
I knew all the questions because all these things were simply I did it like that 49. I got 56. So somewhere some silly mistakes I have done.
Okay, fine. Okay, so let's solve this. After, how do we solve this question?
Okay, all right. So, okay, would anyone else like to take this one?
One is answering here. Mahi, Ravina.
Yeah, hello, Vikram. Are you there?
Yeah, Vikram.
Sir, skip this question and move to next question, sir.
If it is easy, do it fast now. Why to have so much emotion? Ravina. My God. Okay, how do
See,
we start this?
the approach is
Remove
the
it.
same, right? So you just, I'm sorry, yeah. So the approach is same. You kind of draw the lines and all that, and then you see what all are overlapping, right? Kind of eliminate them, and then you'll get the answer. So that is the thing.
How many meetings can be scheduled at most by following the time constraints? Okay, so how I would do is basically start with the one with the lowest,
Yeah, end time.
correct. So lowest ending. So I'm choosing M2. Okay, so which means 2 and 3. So anything which is
M8, 3 and 5.
yeah. So we'll remove this, right? Is it allowed to start after that?
Yeah, you can start at 3.
Yeah, we can start with 3. Okay, that's okay.
M8,
So
yeah.
so we have chosen M2. Fine. Now this is done. We'll go to next.
M8.
Yeah.
Yeah.
I think I need to strike out this also, right? This is
Yeah.
conflicting with M2. Good. So next is the next lowest ending time, which is M8. I'm choosing M8. Okay, so I'm removing that. Anything which is conflicting here is basically this one, right? I think that's all. So now we take the one with the next conflict. I mean, next earliest one, which is 9. So I'm choosing this M6. I'm removing this, so, which means this is conflicting with that, and I think this also is conflicting, right? So now next we choose this and this. Okay, so 1, 2, 3, 4, 5. Answer is 5.
Yeah.
Okay, so if it is so easy, people do it fast at least. Yeah, that's good. Okay, so Ravina, you want to do this question? She
Sir,
won't
I
answer it.
just passed, sir. I don't know.
So that's why
And
we
I
are doing
just passed by guessing.
that's why we are doing this. Okay, what is this question? Maximum number of inversion pairs possible in an integer array of size 2. I think we have done this, right? We have seen this similar.
Yeah. That formula is there, no? N into n minus 1 by 2. That's formula.
Yeah, n into n minus 1 by 2. How do we get that formula? We even know that, right?
Yeah.
We can take some examples and derive the formula also. So this is n into n minus 1 by 2. Yes. By 2, 66. Okay, this is fine. Anyone wanna talk about this? Mahi, you have any doubts or something? Is it okay? Okay. Seems like everyone is fine. Go ahead. What question is this? Someone take this now. Vikram, you wanna answer this? Vikram?
No, I cannot. I failed the quiz too.
Bro, what are you saying?
Yes, I was very overwhelmed with the other subjects.
Really,
Okay.
Vikram?
Oh my god. Now I'm not even. How should I go ahead?
Vikram, you're lying. Vikram, you're lying now.
Okay. Vikram, can you try this at least?
I mean, yeah, but I don't think so. I would arrive to the right answer. So just
It's fine. It's fine.
we will
Even I haven't done the quiz. I didn't even write the quiz joke. Right. We
right.
can
So
do it.
just we take a example of five vertices, and then
Okay.
we just take a like random
So what is
example.
this question here? What is this question?
Let G be a connected graph with at least five vertices and all edges in G having distinct weights.
Yeah.
Let G be the minimum spanning tree of G. So we just take an example of five vertices and then
Okay.
give a weight to each edge.
Hmm.
Then I think it will be a bit clearer. You draw this graphically.
Okay. So I don't have my pen here. With at least five vertices and all edges having this. Is it like completely connected graph or is it just connected, right?
Connected, yeah.
And we can just have
Right.
I'm just drawing a simple one. Is this fine?
No,
Have
take a
one of the
diamond.
cycles
That will be
so
good.
that
Take a diamond and put a center one. That will be correct.
yeah.
Because that's where this problem fit. I saw example in discourse forum.
Yeah,
What
this
you
is
do?
I was actually going through today.
I like tried drawing a pentagon and then naming each edge with different weights. Say 1, 2, 3, 4, 5.
You want me to put a pentagon? Fine. I believe I'm drawing pentagon correct.
Yeah.
Okay.
Just maybe have maybe later, but okay. So you should try having one cycle at least. So
Yeah,
maybe
yeah,
later.
we'll do
You
it.
can add
We'll
one
do it.
later. Yeah.
I'll just name it. I don't have a pen.
Put some middle line, Gokul. That will be easier to go through this question.
I think it got to have a
5 to 2.
cycle, right?
Put a 5 to 2.
5 to 2.
It's
Yeah.
given
Then
cycle.
this question will fit actually. Yeah.
Okay,
In
go
the
ahead.
options it's given, like option 1, 2. Yeah.
Oh, we have the options for that?
No, not that. The point number 1 and point number 2, it says if E is the heaviest weight in a cycle in G. So there should be a cycle to understand the explanation, right? Like
Okay.
Try to understand if that edge will be included or not.
Yeah.
Yeah.
So
we need to do some weights. Go ahead.
Some weights, yeah. Put some weights to the edges.
Can you just tell some? Name some.
Like 2, 4, 6, 8.
It also 0.
It's okay. It's okay. Why do we need a 0 weight?
Can you just swap 4 and 10?
Okay, you want me to swap 4 and 10? Okay.
So yeah, the way I tried to solve this was then you try drawing a minimum spanning tree. So obviously the lightest edge, 1, 5, would always be part of the tree.
Correct. Yes.
Yeah, and the heaviest edge is 10.
No, heaviest edge is 12.
It's 12, but the heaviest edge in the cycle is 10. So
okay, the question is asking about if E is the heaviest edge in a cycle in G, then T must exclude it. Is it true or false?
True.
True. Okay. So we are excluding this ideally. Yeah, go ahead.
So 1 and 2 is correct.
What is the second option? If E is the lightest edge in the cycle, then T must include it. That's true, right? That's true. We have seen this.
No.
Yeah. Okay.
No.
It might not always be true. We'll find a reason why. And go to the third one. Maybe the second one is hard to explain. Third one we have to change the example for the second one. For third one, go ahead to the third one.
Yeah. Go ahead, Vikram.
Can someone else please take it? Because I was not able to solve this question.
Okay.
Vikram,
I
have a
have
question.
pasted an example. Gokul, can you go to the example I have pasted from the discourse? That actually speaks well for the example. Atul has
Vikram, I have
explained
a
this question.
question from you. Wait a minute. I have a question. Like you approach, like excluding 10.
No, in the cycle one, connecting 1, 2, and 5, 10 is the largest, right? And you're excluding that because you would just choose 2 and 6, like the smaller weight edges, right?
Like, but if we consider whole pentagon, then 12 is also in cycle, no?
Yeah. So if you look at the cycle forming from 5, 4, 3, 2, you would actually remove 12. You won't remove 10. So in the end, you'll actually not have 12 and 10, right? In the graph, you won't have 12 and 10. The weights 10 and 12, you won't have it in the MCT or minimum cost spanning tree. It'll just be one line. The edge weight will weigh 2, 6, 4, 8. Only this you will connect.
Ravina,
right?
did that clear your doubt?
Yes, sir.
Yeah.
Sure. Okay.
No, sir.
Okay. Yeah.
Okay. See, your
Okay. Let's
question is
make
that
the minimum cost spanning tree. No. Let's make it Kruskal way. You would choose 2. You would choose 4.
okay. But this.
Yeah. You would choose 6, and then you choose 8, right?
That's all.
Okay. Now let's look at the question. The red part, right? We can see that there's a cycle between 1, 5, and 2. In that cycle, the largest edge is 10. And that edge is excluded because if in a cycle you would choose in a cycle of 3 edges, you would choose the 2 edges which are minimum. You exclude the heaviest one.
Yes.
Right? Yeah. Similarly, in the cycle 5, 4, 2, 3, like the square, right, or rectangle, right?
Yeah.
The largest edge is 12.
Correct.
You would exclude that. Yeah. You would ignore. You would remove. That wouldn't be there in the minimum cost spanning tree, and that's why you got the green one on the bottom.
Ravina, I think this is okay.
Yes, sir.
Yeah.
Okay. So the second option is the tricky option here, right?
Yeah, I think the discourse, this thing explains it really well. But it's like in trial and error. You should try to see different ways of.
Yeah, Gokul, can you show the example? Yeah, that Atul has given one more example also. I don't have this. This I have. So it depends on example.
Yeah,
see,
I
in
also
the second
remember.
cycle, 3 is the lightest weight. Still, we are excluding 3. That's
Correct.
what Atul is saying.
Yes,
So
yes.
I saw this before exam. That's why I attended.
I think we were also there, right, while discussing this question.
Yeah.
See, this was from previous question, I think. Was this? Yeah,
I
it was from
don't
previous.
know, but it was answered now. Maybe somebody would have asked, but I saw this now before exam. So this is a perfect example. 3 is the lightest edge, but still we are excluding, right? The second cycle.
The point over here is that if the lightest edge on a cycle could also be the heaviest edge.
It could be it could make a cycle in another.
Yeah. So now I think with this example, Rana, can you understand? It is easier.
Vikram, I guess.
Yes. Yes, it's clear, sir.
Vikram, fine.
Yes.
Yeah. The second point is telling us that the smallest edge in a cycle will always be included, but that might not always be true, right? Yeah.
Okay. So we need more presence of mind during the exam, right?
I think the proper example leads us to correct.
Yeah.
Our example should be perfect. Yeah.
So what is this question? If we try to find the shortest path from 0 to all nodes, which order will the nodes be marked as true in the visitor dictionary? Okay. Has anyone done this, or how do we do this?
I got it. It's just the Dijkstra. You just go ahead with the Dijkstra algorithm.
Okay. That's all. So from here, if we go to 1, then it will go to 5, I believe. Right? So after this, using the Dijkstra's algorithm again, right?
Yeah.
Is there any clash, like any time where two vertices are finishing at the same time? I can see 4 plus 6 is not. 4 plus 6 and 6 plus 5 is not.
Yes.
I don't think it's there anywhere actually.
I think see, it's coming. So 0 to 5. So 5 plus 6 plus 3 going to reaching this point, and yeah. See, I think these sum up to 14.
No, but wouldn't you go to 6 through 0 to 1 to 6? Like, wouldn't you take that because that's less, right?
Yeah, that's correct. So here it will reach 14 around.
I'll just try to bring it quickly. I think it's 0, then it's 1, then it's 5.
Correct.
Then it is, let's say 10k bar. Okay, so at 10 you're reaching, yeah, then it should be 6. Then it should be 2, 4, and then 3, right?
Yeah, 2, 4, and then 3. Yeah, right.
Yeah, okay. Yeah, no classes. Yeah, you're right.
Yeah, no clash. Easy one.
Yeah.
How much was that? Okay. So next question. Insert 15, delete max. Consider the heap. If we perform the operations in the given order on the max heap, then the resulting max heap would be okay. Okay. So we have done such similar questions.
Yeah.
Okay. So I don't have my pen. Oh, it's already a max heap, right? So
yeah.
So this should come here. 20, 10, 12, 8, and 9. Oh my god, did I give? Okay. And this is 9. Okay, now we have a heap. Please adjust with this and please someone answer this. Don't wait for me to finish it, guys. No one. Mahi, are you here? She's not able to talk. Ravina, can you take this?
I don't know, sir.
Okay. Just Shivani, you want to say?
Yeah, I'll explain it. Yeah. Sure. Okay, so if you insert 15, I think it'll come to the left of 12. And you'd compare it with 12 and the 15 will come on top. So you can just erase that 12 and make it 15.
15. Okay.
Yeah. And then 12 will be on bottom. And once we delete 20, yeah, let's just keep it like that. Yeah. Once we delete 20, 12 will actually go on top there and it will bottle down to the right side. Again, so 12 will come back to its original position and 15 will be on top actually.
It will be on top, right? Yeah, it's simple only. We have done more complex. Wait a minute. Okay, 15 goes up, right?
15 goes up and 12 comes to that its own spot. Yeah.
Correct. 15 and 12, and this is right out. So now the new heap is 15, 12, 8, 9. 15, 10, 12, 8, 9. Okay, this is okay. I think it's okay for all. Should be fine. Next question. Yeah, Uma, you want to take this?
Yeah, I think. Okay. Consider the following statements. Time required for searching an item in a min heap of size n bounded by order of log n.
They're saying that maximum time to search the.
Okay. I think we have to find what are the statements, true statements.
Correct. Is the first statement true?
No, right? For heap it is n, right? I remember. Am I correct?
Yeah,
Okay.
you're right.
Time required for searching a balanced binary search of trees size n is bounded by order of log n. I think, is this correct?
Balanced binary search tree.
Yeah.
Is it like? Are you saying it is, or are you saying it's not? I can only tell you if you're right or wrong. I can't answer it for you.
Is it true
Search.
or false?
Let Uma answer. I just want to know what she thinks.
Time record for
False.
search.
False.
Why do you think it's false? So, what is the height of a balanced binary search tree?
Login, right?
Yeah, it's all log n, maximum log n plus 1. So that plus 1 doesn't matter. But yeah, so whatever item you're searching for, you just have to go at most log n steps, right?
Yeah.
So it is bounded by order log n.
Yeah. Okay.
Yeah.
A
So the
binary
second
tree,
statement is true.
correct. Yeah. So a binary tree can be reconstructed back if either its
So
pre-order or post-order traversal is known. True, right?
One second.
It is true.
Ravina, go ahead.
it's login because it is balanced.
Yeah.
Yep.
A balanced
Okay.
makes the height of the tree log n, right? So no matter what
Yeah.
item you're searching for, you just have to go through the height of the tree, which is log n, maximum log n. Yeah. Sorry, Uma, you can go ahead. So yeah,
Yeah.
either it's pre-order or
Third is
post-order.
correct. Yeah. We can bring back the reconstruct if we know
Yeah,
pre-order.
yeah,
That is
right.
fine. A binary search.
Post order, we have the top one.
Yeah,
on the,
we did it in the revision session. No, we can construct back. Yeah.
Do we need both, or do we need only one of it? I'm actually
No,
I'm
one is
not
enough.
ready.
One is enough.
One is enough.
Okay.
Actually, may I speak?
Yeah, go ahead. Hey, Ankit.
I think we can construct either of pre-order or post-order if that is a complete binary tree. Otherwise, we can't construct. We need two, in order and pre-order, to construct a partial binary tree, right?
Yeah, I think we need two things, right? Don't you think? We can't do it with just one of the above. We need to know two
Exactly.
things for yeah, you're right. Even I think that's true.
No, but
Yeah.
Gokul, we did it with only with pre-order. You remember, Gokul?
Yeah.
Maybe it was a full binary tree. Yeah.
That was a full.
We did it. We constructed in a previous question. Yeah.
So let's directly go over the statement 2 is true,
Okay.
which means that option is false.
Okay.
Okay. So
Maybe we can search it up. I'm not sure. I'm not sure we covered this in any of the lectures, right? They don't cover this part.
But we're during revision session, we tried to solve that, reconstruct it from the pre-order. I don't know how we did it, so that's why I remember.
actually, we
Mhm.
took,
That
we
was
took
a complete binary tree. When there is a complete binary tree, only one order is sufficient. If it is partial, then we need at least two, either in order or post order. Even pre-order and post order we can't construct.
Okay.
We
So
need
it's
Yeah, we
not.
need in order for sure. Yeah, we need in order for sure, and one more of it, right?
Yeah.
Yeah.
Yeah. Okay. So he's saying that if we don't have a full binary tree, then we need, because we won't know where the gaps are, right? Then how can we can't do it without both, like two things, the in order and the pre-order or post-order. But if it was a full binary tree, then you can just choose one of it.
Okay.
So actually coming to the point, if it is a partial balance tree, I mean binary tree, so you guys are saying that we need in order.
Yeah.
Right?
Plus
along
one of
with
the
that,
one of
along
the
with along with that, we need pre-order or post-order. Hope I got the point correct. Am I right?
Yeah. Yeah.
Okay. Okay. Can be reconstructed back if its in-order traversal is known, which is not the case, right?
Yeah.
Yeah.
Okay. 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 And should we discuss more about that previous point? Uma, do you want it?
No, it's fine. I think we need a hint of complete, right? Then only the question will be right?
Correct. So do we need to try it out? Okay, let's move forward. Huh?
No, it's okay. Yeah.
Okay. So what is this? Ankit, can you take this? You're new here, right?
Yeah. This question.
Yeah. Take this.
Okay.
Read the question. Read the question.
Yeah. That's the question. This is quiz two questions, right?
Yeah. Just two questions. Yeah. Read it aloud.
Yeah. Okay. While inserting the elements, these elements in an empty binary search tree BS tree in the sequence shown, the element at the maximum depth are. So okay, yeah. So like I know how to solve them, but I am a bit hesitated how to illustrate it here.
Okay.
Yeah, I can tell. If you start, I can tell which process will come next.
Yeah, tell me. What should I start with first? 20, right?
Yeah, first 20.
Okay.
And then next element is 60, which is greater than 20. Then it will go to right.
Okay.
And then there is 10, which is go to left of 20.
Yes.
And then there is 45, which is greater than 20 and less than 60. Then it will go to right or left of 60.
Correct.
Yeah. Then 65 again, right of 60. After that, 30 will go to 10. Oh, sorry, 30. Okay,
Yeah.
it is greater than, yeah, here. Right. And then last is 90, which is greater all among them. Then it is right of 65.
Okay. So which clearly proves that 30 and 90 are the maximum depth. Right. So that's the answer here. That's clear, right, for everyone? Just a normal simple one.
What would be interesting if they asked us to do the same thing for a balanced binary search tree, because in that sense we'd have to like
Do all
do
the
the rotations and make
rotations
sure.
and stuff.
There is
We
next
have
process.
an example below for that, Steven. It's coming.
Okay.
I made it wrong. Yeah.
Okay, good.
Yeah,
Okay.
this is easy stuff. Like
This
you have to
is
just enter the mean. Yeah, this is easy.
okay.
This I not easy actually. I am a mediocre student. I don't know why I always score 70 or in between 70 or 70. What no matter how easy how tough the paper is.
Plus one.
Yeah, like I want to get rid of this range, but still scoring the same.
So how many times I has been repeated here? So I think how do you do this? How do you solve this?
Yeah, basically I count the frequency. Basically stats one we do mean mode median. This
Okay.
same kind of question. So I count a number of i's, then t, then m, b, and
So we have
accordingly.
we have 6 sides here. Okay. So what about T? Let's try to solve this. Just
Yeah, sure.
So how many T's we have? We have 4 T's. Right? I mean T M. How many M's we have? 2. What else is left? D. It's 3. S is 1.
Totally 16.
Yeah, I think we have covered the 16. Right. So we got the frequencies and all these things.
Yeah, he's saying write it down because we need it for division.
Sure.
Yeah, just to make sure.
Yeah.
This is the confusing point. Actually, I am counting in the paper. Like it should be 15. Why it is 16? Then I count the letters again. Oh, it is 16. I am right.
Mm-hmm.
Okay. Go ahead.
So as usual, first node we will start with nodes. Or first we will count the frequencies by dividing it by 16.
Oh, you want me to do the frequency? So why do we need to do that? We know that this is the heaviest and
We don't require it all. Yeah.
Yeah.
We have to sort it, Gokul. Sort it and then combine it.
Sure.
Yeah, we can just pick the smallest two, right? Smallest two is M and S. Right?
The smallest two is M and S. Okay.
So so we update the list to MS3.
Sure. Okay. MS is 3.
Okay. Why don't you copy the entire table and we can make the first step, second step, third step. To copy that entire text, yeah.
This whole one or
the I6, yeah. Just copy that entire thing.
Wait,
no,
I6.
Your text, yeah, one you wrote.
I can't copy the text. It's
Okay.
So tell me
Maybe
what you want.
Go inside the text. Then. Okay, so
I can't do that.
Yeah, 1/16. You can put the values soon. So I was thinking you can make the values. Sorry. Okay, you go ahead. Sorry, I'm so sorry. Just make the frequencies stable first. Yeah. In sorted order would be better because.
It is
Okay.
already sorted.
It's already
Yeah,
sorted out. No?
B,
No, no.
B.
Small
B
to.
It's already okay.
No, ascending is okay.
Yeah, ascending. You mean small to big.
Okay, you want. Okay, let's do it first. Okay, this is 1.
1 by 16. So
you want me to write it by 1 by 16? Okay, good. 2 by 16. Then should be equal to 3 by 16. What do we have next? T equal to 4 by 16. Then I equal to by 16. Hope it's okay.
Afan raised hand, I don't.
After, go ahead.
Yeah, no, I was just saying that if you want to copy the thing, right? So what you can do is you can just select the thing and press Control, and while pressing Control, keep it pressed. While you are pressing Control, you can just drag it, right? So that will be automatically copied, right?
Wait a second.
That is one way to do it.
Repeat. I selected it.
Yeah, and then you can press Control, and then yeah, that way.
So he wanted me to copy the text alone.
Oh, is that okay? Okay. The text, I think, yeah. Once you get out of the text mode, it will just become an image. So.
okay.
Correct.
Yeah.
Okay.
Go ahead. What's next? Hello. What's next?
I think who was answering? Ankit, right?
I do it different way. Like I just start with node and then put the highest frequency in the left and then moves continuously like that way. It's
Okay, so but do you think that always
it
gives
won't
the
work
same
always.
answer?
It won't work always, right?
Yeah, in both the cases it works. Like this is bottom to up. I followed top to bottom. It depends on person to person.
But
No. Actually, to be honest, so whatever you said, right? I've actually explained this before. So that is actually one of the older encodings. Shannon, I think Shannon, right? I think Fano and Shannon. I'm not really sure of the names. Those Shannon's encoding and this encoding is different. So the one you said, right? Taking the bigger one on top and then going down and putting the smaller ones down, it might not always work. I can give you an easy like wrong example for that, right? You can check one example which will be on Wikipedia actually, and the bottom up approach always gives the right answer. So that's Huffman's encoding.
Oh, thanks.
Yeah. So sometimes in the exam, if they gave an example like that, and you tried up to top to bottom, and you got the wrong answer, yeah, I just didn't want that to happen.
Mm-hmm. Yeah, and they will definitely going to give that option only.
Yeah, in the
exam, obviously.
It's better to do bottom to up.
Most of the time they won't give it, but let's go with the proper one. Uma, I think you were going correct. Go ahead, Uma.
Yeah, because in the lecture and live session they have taught like that only. You go from smallest one, take the two smallest one, and then just add up. That's all. Like a tree, form like a tree. For here 1 and 2, and then 3. You can count 3.
Okay, what do you want me to do?
Write the 1 and 3 in that circle.
In this circle, right?
Yeah, 3 there and 1 in the left. Yeah.
Okay. 1 on the left.
Just add up that, and then 3 will be the total, right?
Wait a minute, 3 or 2? 2, I think, right?
So,
Masi.
1 and 2, right?
Yeah, 1 and 2.
Total
okay, the total sum will be 3.
Yeah, 3.
Okay.
Then we have to check what are the minimum again. Then 3 and 3, right? You can add 3 and 3. B and 3.
Yeah, I think the better way to do this is first do the text slowly and then finally just write the graph. So what I was saying was you have now SMBTI. Now on the next table, just next text box, just write SM equal to 3 by 16.
Exactly. That's what I was
SM is equal to 3 by 16. And the rest is the same. So if you can copy it, that's why I asked you if you can copy it, but it's fine. 3 by 16, 4 by 16, 5 by 16. Yeah. And again, keep this in ascending order. Yeah. This is already in ascending order.
We'll go this
way. Now you put SMB equal to 6 by 16, but you would put T first. Right? You would put T is equal to 4 by 16 first, because that's lower than 6 by 16.
Okay. So now what is happening is we are these 3 and 3 we are adding it up and making a 6, but while writing it here, we need to write it in sorted
Ascending
order.
order. Yeah.
So, Ankit, you understood what happened?
Yeah. Aniket, sorry, my name is Aniket.
Okay.
Okay, one point. The much easier way is write everything in ascending, like in what I say, in a horizontal line. Then if you join it as a tree, so while finding the Huffman code, it is not that. It will be easier to find the code for us. Like 0 1, left is 0, right is 1, like that.
No, I don't understand. Sorry, what are you saying?
No, in the sessions they have taught like write all the bottom like in a line, single line, horizontal way, like 3 nodes. Then combine all the nodes. Finally, you will be able to get the Huffman code.
Repeat. How did you tell?
That's what is happening in this text actually.
No, it is little. Yeah, I don't know how. Finally, you draw the code. That tree mode will be easier. That's what I meant to say. Drawing a tree kind of thing. That's what.
Yeah, that's true.
No, sir. Please first complete this one.
I'll complete this. Yeah, let's complete this.
Let's complete this.
I'll show you. Yeah, I've actually took a live session on Huffman encoding, and I remember I did it this way, like whatever you're saying, right? I wrote the notes down and then I combined them one by one. Yeah. So TSMB is equal to.
But that is 10 actually. So we need to write I equal to 6 by 16 first. Then TSMB equal to 10 by 16. Right?
Yeah, now you have 2 nodes. So now you can start breaking up. So now you can make the graph.
Okay. So which means?
So first will come normal dot, and then on the left you can write the I, and on the right you can write on the right you can write TSMB.
Okay, I can write I directly.
Yeah, I just write I because we know. Yeah, right, TSMB here. Now we started with this. The next iteration will be. Yeah, we need to split that up. We know that we join T. Yeah, T will come there. Yeah, and SMB. Now you can make the top one a circle.
Yeah, now this we can split
TSMB make it. Yeah, okay. Now you can remove the B.
How did SMB get done?
Yeah, B and SM.
Is it B and SMB or SM and then B?
Yeah, whatever is fine. So the right left really doesn't matter.
Achha, okay.
Because the encoding is going to be the same.
B, okay.
Now S and M, yeah.
And okay. So now I'll just draw the circles wherever I go ahead.
Yeah. That you don't. Okay, you should not have that SMB and stuff. Be nothing there. There should be nothing over there. Like there should be empty node. I just circle the vertices. Others should be empty nodes. Yeah.
I'll take a different color.
Yeah.
So okay. So shall we write the encoding for this?
Yeah.
Okay. I is going to be left hand side, which is 0, right? And can someone tell? Aniket, now this is new for you, right? Can you tell?
Yes, sorry. Actually, I was.
Okay.
Which one?
We are just trying to write the encodings here, nothing else.
Okay.
1 for B, and what is going to be S?
S.
So S is over here, right? You travel right, left. So which is 1 1 0 0. Okay. Is this new for you, Aniket?
No. I do some practice of this also.
1 1 0 1. Okay, here we go. Yeah. So we are arrayed with the encoding. Now we can do the calculation, I think, right? Shivanai?
Yeah. So 1 into 6 by 16.
Yeah, 1 into 6. 1 into 6 by 16 is equal to point. Should I write?
Hey, 1 second. I'm just getting a call. I'll be back.
Gokul, it will be easier to just add. Finally, we can divide by 16. That will be much easier, Gokul.
Okay. Go ahead. that's correct. That's correct.
Yeah, because
So,
it's very difficult to do every time by 16. Actually, we don't have to do that by 16.
okay. So we have 6i, correct? And then how many times 4 has been repeated?
1 into 6 plus 2
1
into
into
4.
Plus
2 into 4, right? 8.
2 times 4. Yeah, right?
Yeah,
So
and the 3 into 3
times,
is 3, right?
okay.
And 4 into
4
1.
times. Wait, into 1, okay.
And 4 into 2 for m.
For m, it is repeated twice. 4 into 2. So we got 35 divided by 16, 2.18.
Yeah, that's answer.
That's good. Okay. Is that clear? Okay. So again, summarizing, how did we do this? Just for everyone. So we have all these letters. So we counted the frequency. Okay. And so we combine the lowest two frequencies. So we have S and M here. So yeah. So we have combined S and M and 3 by 16 this. So again, we combine the lowest two and then it's which is S and B, and we are writing it in ascending order. So again, SMB and then T and 4. So it became TSMB, and yeah, we are writing in ascending order. Now, once we have two nodes, so we are going to write it I and TSMB on the left and right. So left hand side we write the marking frequency. Okay, how do left and right doesn't matter, right, Uma? It
Yes,
doesn't matter.
Gokul.
Okay.
We need number of bits, so the bits doesn't matter.
Yeah. Okay. So TSMB is here, and then we just split it up. We just split just like how we have added it here. So T and SMB on the right, then SMB has been added up basically, SM and B, that's all. Then we come up with the encodings as we can see here. And then for the encoding, we just need to do the calculations. In this case, we have 1 bit into 1 into the number of times I has been repeated, which is 6. So TS, how many times T has repeated? It's 4 into 2, 2 into 4. Next we have 3 bits into B has been repeated thrice. And then we have 4 bits, 4 into 1 plus 4 into 2. So ideally if we sum it up, we'll get 2.1. 2.1. I mean sum by 16, right?
Yeah.
Okay. That was a good discussion. Is anyone else want to say something here? Okay, we'll go further. So, Aniket.
No, please continue.
Yeah, so this is the actual way which we need to do it, okay?
Yeah, I will remember that. Thank you.
Yeah, sure.
Sorry to interrupt, but one thing I want to ask, like I am, I know it is not the correct place to ask. I am struggling in DBMS a lot, but I went there, the classroom was empty. And in the mock session, I am working profession. I can't able to join most of the sessions.
Okay, Aniket.
Yes, please.
So I have the DBMS mentor. Okay, so I'll connect with you to him. So whenever he is taking sessions, I let him know you. I mean, let him tell you that, or you can join his group. I think I have the group link.
Yeah, it is great help to provide the link.
Yeah, I'll share it.
Not in DBMS, very few marks, and in this
Yeah.
8th, 10th, 10th, it's a little tricky for me.
Yeah, okay. So I'll share it after the session. Okay, 9 o'clock. Is it fine?
Yeah, absolutely fine. Thank you.
Yeah, sure. Okay.
1 second,
So
I
what
wanted to ask. 1 second. So Uma, this method, was it did you understand this method? Like, did I do it wrong? Like, what were you saying?
No, I didn't do it wrong. It was little tougher than what I learned.
Okay.
It's just simple. Write the codes and circle it and just keep on make the tree and that's it. You just instead of you're doing it second time only, you're forming the tree.
Yeah.
At the base level itself, you write everything in sorted
I
order.
think that is
Just
the right
join
way
the
to
things.
do it. The right way to do it. I just didn't
It's
want
not
Gokul
much.
to draw
Only.
much. Yeah. I mean,
Yeah,
he said
it's
he
a
didn't
cool
have
thing,
a.
but you are having more steps, no? That is only one step. That's what I told. Nothing else. It's the same. Yeah.
Okay.
It was more
More.
simple than that. That's what I told.
Yeah, that's
Instead
right.
of,
Mhm.
yeah.
Okay, it's more simple in the sense to understand or to
To
even
solve.
pick it up.
To solve
Okay.
it.
Okay. Okay. Maybe I look into that thing. Yeah.
Yeah, Bhaskar told even, yeah, that's what I learned from
Is it
YouTube.
on one of
also.
the live sessions? Maybe you can send me the link.
Yeah, I'll search. Yeah, I'll search.
Okay.
You are in
Okay.
WhatsApp, right? I'll search it.
No problem. Yeah.
Yeah.
Okay. So next question. Who would like to take this?
From this question onwards, everything is wrong for me. Especially this question, I did not understand. Somebody, please explain.
For me also, this is wrong.
Okay, let's read this question. Consider a random sequence of positive integers x1, xn. We have to partition them into two sets, set P and set Q. Find such that the difference between the sum of the two sets is minimum. All right. So they are in random sequence. Okay. So which of this following greedy strategy would work for this problem? And again the answer is none. Okay. So what's the first option? Can someone help here?
Does anyone know how to approach such a problem? Is this the first type of problem we are getting in the quiz, or was there a last year's
This is the
paper?
first, no, this is the first time we are getting such a type of question.
This is the first time we are seeing such. I didn't even
Because
understand.
we have solved the previous term question papers. So
Yeah,
we know that.
So
And the
have
option
you
is
guys
none
gone
of these.
through the? No, that's all. Okay, so if you've gone through the greedy strategy videos of week 7, is it? I think greedy strategies.
Yeah, week 7 we have greedy strategy.
Yeah. So I remember going through them, and I remember that so we can have many greedy strategies, right? What is one way to know if a greedy strategy works or not, right? How do we prove if it works or not?
By showing it, I mean, a false case where it doesn't work.
Exactly. Yeah. Just a counter example, right? So I think that's the whole point of this question. So if you're able to come up with a
Counter example for this option.
counter example, right? Yeah, you just have to remove them. Yeah, there might be cases it'll be hard, but yeah, just see how we can. Let's see how we can do it. Yeah.
In between exam, I don't know what happens. No counter exams are examples are coming when we have to select. I think I selected as option C.
The options you selected option C, is it?
Me too. Because I know that first two is wrong. The third one I don't know, so I choose the third one. I thought none of these will not be option. That's why.
Okay, let's see.
This one was a little tough to understand. The first one was.
So Uma, you told that you are done with the first two options, right? Can you give us with an example, counter example for this?
Now I really forgot how I thought. I'll just think a bit if I can get it out.
1, 2, 5, 6.
No, one example is yeah, let the last number be very, very far away from everything else, right? So let the
1,000. Okay.
Yeah, exactly.
Okay. So now what does it say?
Okay, maybe this is also not wrong. Wait, let's think about this. 147,000.
147,000. Okay.
Yeah, 258. All we have, right?
So
Should also include 999 in it.
why? Do you have any reason for that?
Yeah, because for the first option we are doing now.
Yeah. So why is this wrong and why is that correct? Can you help us? Because even we are trying to understand. If you know it, Ravina.
Sir, okay, sir, proceed how we are doing.
No, so all I'm saying is, Ravina, like what I'm trying to do is in the first option is, see, if I want the sum to be sum between the list x1 and x2 to be least, right? In one list, I want 1,000. The other list, I don't want the 1,000. So in that sense, I would have to choose the smallest 3 elements and pair it with 1,000, or smallest 2 elements and pair it with 1,000. And the other element should be there in the second list, right? That's the only way you can get the minimum. So 1,
Yeah, I
2,
was
and 1,000 should have been, yeah.
I was thinking like it's written put all even in one and odd in other. So if there will be 19991 and if we subtract from 1,000, then we will get one, which will be the minimum most. Comparative to this example, we will get a value higher than that minimum. So it will be false. Option 1 will be false.
Yeah, we wanted something to counter the example. So doing this, using this approach, right? This strategy, it's actually going to give us a wrong answer, and we have to show an example of a wrong answer.
Wrong answer, exactly. May I tell Srivinay for this?
Yeah,
Okay,
sure.
here the sum is, what is the sum here? It's 1012. Okay, in the first one. Okay, so for the second one, we are getting the sum as, how much is that? It's 15, right?
15.
Okay, so the question is saying such that the difference between the sum of the two sets is the minimum. So what is the difference here? I mean, difference between the sum.
997.
Okay, what? 997. Okay, this is what the sum here. Okay, so the counter example that I'm going to show for this is basically they have they mentioned something like you have to split it equally. No, right?
Google, this is a counter example, no, Google?
No, this is the example they are saying it for. I mean, this is the strategy they are saying.
Yeah, but this is wrong because the minimum difference would have been if 1, 2, and 1,000 was in a list, which is 1,003, and 4, 5, 7, 8 would have been in a list, which is say 17, right? So the difference would be lesser in that case. Do you understand?
Yeah.
So this is
not
this
yet.
is this. Okay. Okay. So what we have to do is this list 1, 2, 4, 5, 7, 8, 9, 10,000. You have to split it. What is the minimum? If I put it into two lists, what is the minimum difference of the two sums of that list?
Correct.
1,000 should have been in one list. Along with 1,000, I should have paired the smallest two elements, right? 1 and 2.
Okay.
So first list will have 1,003, the total.
Okay.
1, 2, 1,000 would have been in one list. That would have been 1,003 total. And the second list, I should have had 4, 5, 7, 8. And the sum is, I don't know, I think 18, is it? 17. No, sorry, 15 plus 5 plus, 24. And the difference is
1003, right?
Yeah.
But sir, if we keep only 1,000 in one list and all the rest element in other list, then we will get
exactly
a lower difference.
Oh, I thought we have to have this. I thought we have to equal limit. Sorry. Yeah. 1,000 and the other element. Sorry. Yeah.
That is what I was about to tell. So just like thanks, Ravina, for saying that. So the point here is that if we have an example like that, so it will that's a counter example, right? So this is saying that according to the strategy given in this first option, we are getting the difference as 1012. Am I right, Srivinay?
Yeah, 997. Yeah.
Yeah. You ignore this. I mean, let's not take this. So the strategy here is put all the even position elements in P. So which means the odd elements. So what do we have done, right? So X1 is nothing but the P. We have summed it up and the rest of things in a different list. And the difference is 997. So if we follow the strategy which Ravina told, so just put 1,000 in the first one and
1,000 minus
that's the best counter example.
27. Yeah, that's a
1
counter.
plus 2 plus 4 plus 5 plus 7 plus 7, sorry, 7 plus 8, which sums up to be, their difference is going to be lesser.
Yeah,
So which
exactly.
means that the statement is wrong.
I thought the elements has to be equal. Sorry, in some sense, I thought the two elements has to have equal almost. So yeah, this is right. That's why this option like the example we have given is a counter example. Yeah.
Yes, exactly. So now going to the second option. Okay, so what is this? Find the median element. Put all elements lesser or equal to the median in P and greater than the median in Q. Okay. For for the same
Okay,
example.
Gokul, one doubt, sorry to interrupt. How
Go
did you
ahead,
put only 1,000? Because it is clearly says put all even position elements. So
Look,
shouldn't
again, all
Yeah,
even
that's why
position.
there should be some zeros. Sir, there should be some zeros between like 1, then 0, then 2, then 0.
because
Then
according to
only
your
we can
sequence,
add up to
2 is a
1,000.
even position element. So you have to take the 2, right? For your
Okay, so
it doesn't work. Maybe like she said, you put 0, 0, 0.
So let's say that they are saying that put all even position elements in P.
Yeah.
That means what are the even position elements in that thing?
2,
2,
1, 4,
5,
7.
7.
2,
So
5,
2, 5,
8.
8. Correct. So P equal to X2. Q
Yeah,
equal to
he's correct, right? He's correct. Q is equal to X1. Yeah.
Okay.
Ma?
Yeah.
Now does it make
And the
sense?
difference we're getting is 997,
Yeah.
but the best difference is somewhere near 980, right? 970.
Okay. I'm
I just
asking.
change the order. Yeah, you go ahead, Uma.
Yeah. Then how did you take P alone? The counter example I'm asking about, Gokul. I'm not getting that.
No, that is the actual answer, right? Yeah. That is the best scenario.
Okay.
If you had to split the list,
So
you would have split it
the
like this.
minimum for the minimum you're telling. Okay.
Correct.
Yeah.
The minimum
Okay.
difference.
Got it. Okay. Yeah.
Okay. Fine.
Remove the one on top and maybe write optimum on the right hand side to just show that the one we've picked on the right is actually the optimum one.
Yeah, that's the one.
Yeah, that's the optimum answer for this example. Yeah.
Right.
Okay. So you're showing that greedy algorithm is wrong,
Yeah,
right?
yeah.
I didn't get it. Okay. Got it.
Okay. So second option, find the median of the elements. So again, coming back here. So what's the median over here? It's 8, I believe. 8 or 1,000. So shall we take the one which is lower to that?
No, median should be the middle element, right?
Middle.
Okay.
5.
Okay, sorry.
7.
Yeah.
5.
So what is the median?
5.
It's 5. Okay. Put all elements lesser or equal to the median in P. So P equal to 1, 2, 4, 5. Right, Uma?
Yeah.
And Q equal to and greater than the median in Q. So which is 7, 8, 10,000. So this is again, so we have the best possible way on the right, and this is proving that this is not going to give us the actual value, right, Uma?
Yeah, right.
Yeah.
So this proves it. Okay. So this is the counter, I mean, this is the validation for that. Okay. Now going to the third option. This is where the confusing part was, right?
Yeah, I didn't even get it. What is it?
Okay. So first 2 points are okay, right? You're okay with that.
Yeah.
Okay. So x1, x2, x3 up to xn from the sorted sequence at ith step. What is this?
It's very tough.
Sum of all current elements is, what is the saying? Shrivnai, can you help here?
Yeah, let's read it slowly. So we have a sorted sequence list and we are iterating over the list. That's all it is. So xi is the element at the index I of the list. Okay. Xi is placed in that set either in P or Q whose sum of all current elements is smaller than the ith step. Okay. Sum of all current elements is smaller than the ith step. So
Okay.
P has a set of current elements, Q has a set of current elements, right? And
QR.
xi is placed in that set whose sum of all current elements is smaller in the ith step. So if I'm looking at a sequence, it's a sorted sequence. The next number I'm looking, it should be lesser than the ith step.
Should go into the P or Q, the sum of elements is lesser.
Right. So they are just
Correct.
putting the elements into the baskets, and
Yeah.
next element goes in the lighter basket.
It seems like the first element is going to go. I mean, let's take the same example, Vikram, here. So in this case, one will go here, right? First time.
Yeah, either place.
Well, one will go to the first or second, fine. So now the Q is having the lowest. So now Q, I mean, the second element goes here. Now the next element, since P is having the lowest, it's going here, right? So we have 5 here, ideally. So again, we have 7. So the next lowest is 8. And then again, this is the lowest again. So we have 1,000. Still again, this proves it, right? So we have the best possible thing strategy to come like this. Am I right?
Yeah. Yeah.
But I think that here is that they are sets, set P and set Q. So in this strategy, if though both elements are same, we cannot put that in that order. Xi is placed in P or Q. Set of elements are same.
Sorry, I didn't understand. What are you saying?
The strategy is working, but they had said that the P and Q are sets, not lists.
Okay.
And
Why
if
does
you are
that? Why is
consecutive
it?
set,
Is it working? Wait. How is it working?
it's not working. That's why it will be wrong. I am saying the third
Okay.
option.
Yeah.
Actually, it's working
How it is working?
because difference is the smallest, na?
No, no. See, we have the optimum list here. Nikhil, are you able to see this right hand side?
Okay.
Right. So the optimum list should be the one, the one list have 1,000 and the other list have all the elements,
Okay,
which is
then
going to be the
sets,
optimal one
yes. The sets
for this
don't matter
example.
then. Yeah.
Yeah.
Is that clear?
Yes.
Okay.
Got it.
Probably we should come up with an example like this. If someone has never pointed that Gokul put the 1,000 over there, I would have never come up with this solution. Seriously. Okay. So is that clear? I mean, why this option is wrong?
Yeah.
Uma, Mahi, you want to say something?
So it all comes to only the example we take, so which is very
Yeah,
good.
exactly.
Yeah.
Yeah.
It's better to take weird examples instead of straightforward examples. Like 1, 2, 3, 4, 5 would might have come true for some of them, right?
Yeah.
We try to make different weird examples, like which could be edge cases, right?
Hmm.
And once you see a pattern itself, you would realize. See, you see that you're putting it in the smaller. Like you see that the best option is when you put 1,000 and the rest elements in the rest, right? So in that sense, if you add anything other than 1,000, like if you add 1,000 and you add something else in that list, then the solution is wrong. So you only have to do the entire iteration or whatever.
No, Srivinay, the point is the thought of disproving didn't come to all of our minds. That's the problem, right? That was your first point, no? That didn't strike me.
That's
But
very
we
important.
all thought one of the example might be true. So that thought didn't come that to disprove it. So maybe that's where the
Even
answer
in the
is.
lecture, sir used to do the same thing, right? He used to keep on disproving the facts. Let's go. Let's take this strategy. Let's take this strategy, and then finally
In
he'll
some
come up with it.
cases, we can disprove the worst case also, right? So we don't know it is really our case. Is this a case that we have to take it to disprove it?
Exactly.
That
Yeah.
is where it is lies, right? Yeah.
Yes,
That may be the worst case also. So we don't know.
that's right.
Yeah. So what you should do is for each, actually what we did is actually wrong. So what we should do is for each strategy, we should have taken a separate example according to that strategy. So that's what I did at first, right? I saw that, okay, we're adding the even position elements and odd position elements, right? If I did that, then I put at one spot, I put either in the odd spot or the even spot, I put one large number. So in that sense, that would have gone to one list and the other elements should have gone to another list, right?
Yeah.
So for the second element, you should have taken something relating to that. So if I saw a median, I say 1, 2, 3, 4, 5, and then I put 1,000, 2,000, 3,000, 4,000, right? In that sense, it's very clear that the second strategy won't work. For the third one, you would take another element, uh, for that strategy.
In retrospect, it is looking easy, but in the exam pressure.
Exam, actually, I didn't even get the question. It was very tough to get that.
Yes, actually, I solved like that, but I didn't take the 1,000. I took just 1, 2, 3, 4, 5, 6, 7, 8, and sorted like that.
Yeah, Afran, you want to say something?
Yeah, so there is this point that I'm not just now noticing. So, given the problem statement, and it is clearly mentioned that all of the following are greedy strategies, would you think that the given problem statement can possibly be solved with a greedy strategy at all?
Yeah, it's a little difficult to say. We have to think of strategies actually.
No, it won't.
Yeah, I think for this problem, I mean, yeah, so If you think it that way only, you'll see that okay, this problem is not at all solvable with a greedy strategy, and what all we have been given is all greedy strategies. So yeah, that possibly is a one approach to solve this one. You can just say none of this, but yeah.
So where do you come up with this point? Like, I'm not from a technical background, so I'm just asking you, how could we tell that whether a problem can be solved using a greedy or not?
Yeah, I mean that I'm telling now. Just
Wait,
now, you. I mean,
Afnan, do you think it can be solved in this way? What if I'm looking at a descending order of the thing and I do the same, the third option, I do the same thing, right? I place it in the set where the sum of all current elements is smaller than in the ith step. And I do it, but instead of doing it in a sorted sequence in like 0 to n, I do it in a descending order. I think it might work. I mean, I'm not able to come up with a counter example for that.
Okay. So yeah, specifically
List
talking about
goes
the third
in
option,
negative
no?
numbers.
Yeah, Anil, sorry.
If list goes into the negative numbers, then it will be a problem.
Negative numbers.
Yeah.
So, but the question is saying that random sequence of positive integers.
Okay.
Okay. Go ahead, continue, Afnan.
No, I was just the previous point that was raised by Shrivne. So you're specifically talking about the third option, no?
Yeah.
Correct.
So if we follow the same strategy as the third option, but instead of iterating through the list in sorted order, ascending sorted order, we do it in descending order.
Okay.
I can see work for the example we have taken till now,
Yes.
right? Because 1000 would go first, and then the rest of the elements, since some cannot come up more than 1000, I would put it on second list, right?
Yeah. So it is still a greedy approach, but it is seems like it is working. Yeah. At
It
least for the
seems like
example that
we
we.
In
might
that
not be
case,
able to come up.
hello.
Yeah.
Yeah.
In that case, the third option should be correct now because they had not said anything about ascending order.
Yeah, maybe you can put it on Discord, tell them, sir, this works if it is in descending order, give everyone
Descending
marks.
order, yeah.
Yeah.
Might get 4 marks.
Yeah.
Come on.
I have one doubt.
Because they are just
Like it's connected to Afnan's doubt. Like he said, it doesn't work, but it depends on an example, right? Because you added 1000. If not, it might would have worked.
And that's the thing. That's the thing, right? You have to come up. So that's the thing
For
about
this,
strategy. You have to come up with counterexamples. You have to
yeah,
keep trying with different edge cases that you think might be edge cases, right?
yeah, okay. But it also works. That's my doubt. It also works only because this example doesn't work, right? There is also example it works also. This there is a greedy strategy exists.
Yeah.
That's my question.
That's the thing.
Okay,
There are examples where it can work, but we have to prove that. That's the
we
thing.
have
If it is, we have to come up
for
with a
this
proof for that.
example, we should take a counter example. That's where we should strike us.
If you're not able to come up with any counterexample, you should be able to prove it.
Okay. Thanks.
Yeah.
No, that is fine. Okay, but my point is more in a general sense. Like so, for example, the example that we have taken, we have seen that it will work in some cases, and the other cases it won't work. So the question is, I mean, the more general sense. So maybe not related to this question at all. So if we know in general that this problem, I mean, assuming that we know that, right? So this problem, certain problems are not in the class of greedy strategy solutions, then we can immediately say that okay, this problem statement, and we have been given options only in the greedy approaches, then we immediately know that is not going to work, right? I mean, we don't even need to try the examples and all.
But is it easy to say that a particular problem can be solved with or without a greedy solution?
Exactly. That is the
It's
key
not
part.
easy, right? You can't classify problems that easily.
Exactly. So that is the key part, because what I am saying just now is because of intuition only. So intuitively, it seems as if
no.
But I think it can be solved with a greedy strategy. And I think I did come up with something which I have to think of it and prove. Yeah.
Prove or disprove it, right?
Yeah.
Yeah, that will be good if you can, post that in Discord also. We
Sure.
might have a look at that also.
In
Sure.
case
Thank
of
you.
positive integers, it will work.
Yeah, in
Does
the
what?
decreasing
In
order,
case
no?
of positive integers, so in descending order, it will work, I think.
Okay. Okay.
And that's a greedy strategy, right?
Yeah, that is still is a greedy approach. Yeah, okay.
Yeah, so the bottom line is if you're really bamboozled with the options, choose none of these.
Okay. Okay. What is this question about?
This
Which
one
of
is
the
easy.
statements?
May I take this one?
Yeah, please.
Okay. So we know that, I mean, that quick
We have seen
select
this.
strategy worst case is enough in square because the approach is the same that is there in quick sort. So the
The worst case.
worst case for quick sort is also n squared. So
Square.
for quick select also it is same. That's the thing.
Straight out of the book, huh?
Yeah,
And to the boundary.
correct.
Okay. So I think
Yeah,
this is the
this
one.
one
Go
I
ahead.
got all of them. I mean, like, what are all the truest statements? I selected that one, but I don't know why I selected the O of E plus V in the extra thing. So that is because I think that I got misled by the adjacency list mentioned there in the statement. So I selected that one also, and because of that I lost marks there. But the Melbourne Ford that I selected, that was correct.
Yeah, but in
SPK,
code can detect the negative cycles,
yeah,
right?
that is true. Yeah,
Mhm.
this I selected the second one. Should not have selected that, but yeah, I mean, made a
Why is
mistake
this
there
wrong?
because the extra is n squared actually. I think. Yeah, is it right now, Shrivinay? I think it is n squared.
Yeah,
When
n
is
square.
the E
But
plus V?
for a matrix, for a adjacency list,
Yeah, that's where the confusion lies actually. I selected that thinking only that it will be n squared for matrix. If it is adjacency list, it should be E plus V is what I thought in the exam also. But then
yeah, let's
yeah,
let's just think about the exercise. What does it do? It goes through. Okay, so it selects the minimum most, right?
Not
That's what
order
it.
of m into n, right?
Yeah, that's what. So it does that thing. I think
Because
it does
each
it.
list it is going through, so
Yeah.
it is m, so it is m into n, the time complexity for adjacency
One
list.
second, but don't you think m into n will make it n squared? Oh, it can become n cube,
Right,
right?
can be,
At the
but
worst case.
yeah, worst case. But as such, it is m into n. I think I may be wrong.
M into n makes sense. So for each set of vertices, you are going through that list.
List, yeah.
Yeah. Can you go down a little?
okay. So
No.
in the adjacency list case also they are saying that it is n squared, right?
N square.
Here,
Yeah,
yeah,
that's
that's the
right.
thing. Hmm. So I was thinking, I think I got, I took it from the BFS thing actually. So I thought that after all we are traversing, so if we traverse like that, it will be E plus V. But then,
Mm-hmm.
That is for you, and then there is one more for loop, no? So that is why I think that
Right.
n square
You're
comes.
right.
Yeah,
Line 9 and line 916.
yeah. No,
Hmm?
I'll be right back. I'll be right back. Sorry, guys.
9 and 10. 10 also you're having.
Yeah. Sorry for that. Yeah, we have. But for V in W list,
Okay, maybe I am also not sure. 9 and
no,
16.
I'm
Okay.
trying to understand this.
Yeah.
Okay, let's go. Yeah, go ahead, Afan.
yeah, that might be the possibility because see what happens is that at each iteration we have to figure out the next minimum distance, right?
Yeah.
So possibly it is because of
Because
that
I
that we're
remember
getting.
the heapify
It's not.
comes.
That's
Uh,
correct. It's not a cube, right? It's n square only.
yeah,
And
because I remember in sir and lecture and live session they told when you're taking min, we are that is what causing the time complexity more the next D. So we are going for the heapify and things like that
Yeah.
to reduce that selecting the min. So we go to the heap and select extract the min. That's which
Okay.
reduce the time
uh,
complexity.
but
I
then
Oh,
remember.
yes,
still
yes, yes.
in
You're right. You're right.
Yeah,
I'm
so
sorry.
that is where I remember it must be from that for loop, so it becomes n square.
Okay, but
That's
then
the bottleneck. Yeah, he explains it, right? Yeah. Sorry.
but then what about the loop in the line number 16? I mean that might
Yeah,
also be
even I
giving us
got confused. I
that
wanted to
possibly because certain nodes we are not going to visit again, right? Because of that visited thing, perhaps that is reducing, the calls there. Because for certain things we might have already visited, right? So we don't
But still, it's
we
a
don't.
loop, right? This is an if condition. Still, loop is a
Yeah,
loop, right?
you're
you
not
don't
doing
go to
anything if
n
you're not
node,
doing
okay?
anything if if condition is wrong, right? So you're just going to the next one without any work.
Yeah, Yeah.
Not only that, no, it is only going through the next of wheel list. We are not going to go through the n, but in the min of thing, we are going to go through the everything.
Yeah. Okay.
Only the edge. Yeah, only the
It is only list, so it might be 1 or 2. So
Potential,
Yeah.
potential nodes that we can visit. So only that, within that we are checking for.
Yeah, only
This
list
part is
was
like
there.
amortized, right? We'll if you've gone through the lectures, or if you have the time to go through again, I think he explained that this part has an amortized time of number, I mean the edges in for each edge, for each vertex, you're going to go through how many times? The list of edges in that, right? And the total number of edges in the end you're going to see are the number of edges. So, okay, I can't explain it easily without like annotating maybe, but maybe you should go through the lecture once, just quickly go through and see how he explains the amortized complexity of the updating distance. I found it very helpful for myself when I was making the activity questions. Actually,
I have one question. Very sorry to ask. At the end of pdsa course, what is amortized? Really sorry. It is very bad to ask at the end of this.
It's fine. It's fine. Even I don't know.
I tried even lecture. I'm not getting Shrivani. That's why I'm asking you.
I was about to ask that question here. What is amortized?
Okay. So, okay, at one call, for something you're working, you might be working 3 say for each call, you're calling something, right? You're calling a function. The function depends on the parameter you passed it, right? Sometimes the parameter passed it might end up taking 10 units of work, but sometimes the same parameter, a different parameter might have taken only 3 units of work, right? What is amortized? You're just seeing what is the overall, if how many times am I calling the function, and for each function totally, like instead of doing 10 plus 3 plus 4 plus 7 plus 8, I'm going to do overall how many is it seeing, right? That's all I'm going to check. So in case of Dijkstra's, if I want to explain, right, I'm just going to say, see, I know that I'm going to update it for each. You're going to visit each vertex only once, right? So I'm going to do it for n times, and how many vertices I have, I'm going to do it n times.
Yeah.
And for each one, I don't know how much it is, but totally, I know that I'm going to update the distance only m times.
Okay.
Right? Something like that. So it's like a not approximation, but it's a tally. Like you're tallying it up and giving a approximated total. To be honest, yeah. What is the Google say for it?
You can take the example of an array.
Can we take it like that? It is not the exact time complexity, but it is approximately.
Yeah, sort of the
sure.
average.
You can take the example of an array.
Sorry, Vikram, I can't hear you.
If you take an example of an array, it will be more easier to understand. Like, for example, in an array, like, we keep adding elements and we keep shifting, right? But there is one time when you have to, double the space in the array.
Oh, yes.
And ultimately, then it is divided across all these steps. So that is amortized.
Yeah. That is actually a good thing, right? Array, you have you give a fixed block of memory. So until that fixed block of memory is used, you use only like one. So inserting is order of 1 and deleting is order of n, right? In that sense, you keep doing 1 and n, 1 and n, 1 and n, how many ever you do it. But at one point, an insert might take might increase the time, like increase the storage space into double the size of the list. So that becomes, you have to create an entire list, entire array, and you have to make insert or delete.
Yeah.
So that happens once in a time. So you don't have to use that as the order of. You can't say it's order of n or n square, right? You just say approximately over all this inserts and deletes, I only do average this much work. Yeah, so I think average is a better word, like Afran said.
Yeah. So in the average case, I think we'll be going on, onto the lesser complexity, to put it this way, right? And eventually, sometimes it happens once in a while that we'll go to the worst case, right?
Yeah.
I mean, and then we come back. So we do it once and then we kind of come back, right? Yeah.
Okay.
Okay, thanks, Vinay. Yeah, got it. I think the space complexity got it. Understood.
Yeah.
I remember seeing this E plus V somewhere using the
even
heats or something.
I also
Official
remember.
algorithm.
That is BFS using the
BFS,
adjacency
right?
limitation. Yeah,
Yeah. Using
BFS using
adjacency list, BFS.
correct.
BFS. Okay. Somewhere heap will be there, right? In heap, some other
Dijkstra with
algorithm will reduce.
heapify. Dijkstra with heapify, there is
Dijkstra.
an
Oh, that is
Exactly.
vlog E actually. Vlog E.
That is what. Okay. Oh, it's V log E.
Yeah, that is
Vlog.
to reduce this n square to take that min.
I remember we were reducing the Dijkstra's algorithm ka
Yeah, using
complexity.
heapify. Yeah, that will, because we can extract the min from min heap, which is
Correct.
order of min. So it reduce that
Oh,
section.
you were also saying it right sometime back.
Yeah.
Okay. Great. Fine. Okay. After you were let's finish off this with this question. Go ahead.
Yeah,
The
sure. So
formula
this one is actually wrong because of the fact that in the second term also, in the second term, in the min call, that
yeah.
also will have to take sp raised to k minus 1. So that is the only, wrong thing in the formula. Sp k minus 1, k to j, and then sp k minus 1, I to j. Sorry, and that also is wrong because you have to check, I to k and then from k to j, right? Like that.
So
Okay, sorry. This one is the comma, no? Okay. So the first, the first part of the comma itself, I mean the left of the comma, we have in the min, I am saying.
yeah.
So
So first part, what are you trying to say?
yeah, so it will be spk, and then
I
we
comma
are
j, right? Or
no.
I comma
I
k
to k,
plus.
I to k and from k to j, but that we will be taking for sp raised to k minus 1 actually, not raised to, but you know,
That's right.
you get the point, yeah.
Iteration.
Yeah, so that is the only thing we have to reduce by 1 the k. So that is why this is wrong. So I did not select this one actually. So that is fine. I mean, but then
All right.
yeah,
So
the shortest path returned by Dijkstra's algorithm always passes through the least number of vertices. That is not always true because of the fact of weights. No,
correct.
you might have another path which you are taking more hops, right? The number of hops is larger, but then you are getting an overall minimum cost, right? In that sense. So the number of vertices might be more, but then the cost is less. So think of it in terms of the weighted graph. That is why this is wrong.
Yeah, that's right. What was the next option?
Okay. The last is given a graph where all edges have positive weights. The shortest path produced by Dijkstra and Bellman-Ford may be different, but the path weights would be same. Yeah, that is true because it might be the case, right? Because they might have a different selection for the uh, same path, because they're not saying that they are distinct. They're saying that positive weights, but there might be a case where there are two weights having equal number, right? So then in that case the selection might be different, taken by the both different algorithms, right? So extra may take one path, Bellman Ford may take a different path, but the path weight overall would be same. But then the choice would have been different in case of equal weights at least. So and then they have not mentioned the fact that they are distinct, so that is why this is true.
Okay.
Right, it might be different. Hope it is clear now. Is it?
What about others?
Yeah, you're right.
Yeah.
Clear.
Okay. Sure.
Okay. So that's all for today, guys. Okay. So it's already
There is
9.
one more. Okay.
Sorry,
We can see next class now.
yeah, 2
I
more
need
questions are
help
left.
in recurrence relation.
Okay, you wanted to ask this question?
No.
So
I want
only 2 more questions. No, Mali, let's finish it off. So after one is starting there, we have like 2 more questions. Or should we take it in the next session? We shall take it in the next session. We can discuss it
ABL3
later.
is going to take some time if you want to take
Yeah.
it. So.
So next session we'll do it. Okay.
Yeah.
Okay. So
This
then, guys,
one might be easy. Okay.
we'll do it in the next session anyhow.
Yeah, anytime. Okay. Bye. Thanks, guys. See you tomorrow. Tomorrow is it on?
What do you guys say?